Okay,
Yeah, sure. I'll try my best. Yeah.
perfect. Okay, so since you know that this is a data structure and algorithm round, you'll be having 45 minutes of interview, and we'll try to cover as many as questions possible. I currently have 3 questions for you, so we'll get started with that. Yeah,
Yeah, sure. Let's go.
cool. So here is your first question.
Okay, so given the root of a binary tree, return the in-order traversal of its node values. Okay, so I assume the root to be given. Okay, so first question is root, can root be null?
Yes, you need to take out a few of the test cases, I believe. Like just try to pick up few of the test cases that you think should be necessary, and then you should be covering out those. And
Okay, so root,
for
if
the
root can be null,
yeah,
yeah, yeah.
and for this question,
Okay,
you can take that the values of the node, like inside the node value, will be present as a integer.
okay. So node values, can they be distinct?
Node values will be distinct.
Okay, and what will be the number of nodes?
You can take that to a high number. Let's start with like 10 power 5. No, not even
Okay,
10 power 5. Let's start with, let's say, 5,000, and then I would see if there is any other thing that, if it is required to be scaled.
okay. So will the root be given as a? Okay, so can you please elaborate on the type of the node or the
Yeah.
type of variable which we will be
The
using?
node structure that you can always expect as like, the left and right.
Okay,
And you can always imagine the int val to be like the value as to be an integer. Okay, and say
okay,
that even
yeah,
for this one, let's try it out 500. So yeah.
okay, okay. So as we can see clearly, n is 500. So we can get an estimate of what the time complexities can be.
Hmm.
Estimated time. So we can pass with the n
Sorry,
square, or we may try
I
with
forgot to start
the.
off the timer. I'll start the timer now. Yeah, please carry on.
Yeah, sure, sure. So we may get n square, or we may try to, if we can get n square, we may try with n log n,
Mm-hmm.
or we may even go to n, but we cannot go to O of 1 because we will have to travel all the nodes at least once.
That is
Okay,
true.
so let's say we have a tree. Okay, so few observations. Observations part 2, let's say. So for instance, let's say this is a sample test case. Let's say if the root is null, so the tree is like this. So we get an idea. We'll have to return a array which will be empty. So we are returning arrays, right?
Yes,
Or
yes,
in a string format.
yes.
Okay, array.
Not as a string.
Okay.
Like you do need to return the values in their original form. So let's assume that as a list you need to return them.
Okay, so this is empty array. Or and what if we have only one node? Then we'll have to return that.
Yes, that as well.
So as per in order definition,
Hmm.
in order definition says, okay, I'll write it. I'll write the definition here. So as per in order traversal definition,
Yeah.
first there are basically three or four types of traversals. The first one is in order. So basically in order, the value of a node is in is in. We get the idea of in from here. So this means the value of the node is between the between the left and right childs. Okay,
Okay.
so let's say if we have a tree which is consisting of only one node, then the output will be one, as there are no left and right sides.
Mm-hmm.
Let's say if we have a tree, let's say I'll draw it in the middle, one, then, and we have something like this, let's say. Oh, 1 second. Okay, so let's say we have something like this, and then so if we have something of, let's say for now, let's assume we have only three nodes, one, two, and then three.
Mm-hmm.
So the in-order traversal for this test case, please correct me if I am wrong. The in-order traversal will be two, one, and then three. Am I correct?
Yeah.
Okay, so I will be using recursion to solve it because we see that the nodes are given uh, in this pointer form. So instead of traversing using a loop, I would prefer using a uh, recursive approach for now.
Okay.
So let's say we are given, okay, so we are returning, that's okay, what we are returning from the function?
You can expect a list. So in the case of, let's say you're using C++, you can return a vector of
Okay, so,
values.
okay, so vector int solve. I'll name the function which receives a node star pointer
Yeah.
like this. Does it work? Okay. Now
So
let's
before
say
you
I have,
code it out, can you like just
yeah,
explicitly tell again what is your space and time
yeah.
complexity?
Actually, I was typing the whole approach here.
Okay, perfect. Yeah.
So yeah. So first thing, if we are writing a recursive, okay, I'll write solution one. Okay, so if we are writing a recursive approach, first one should be the base condition.
Mm-hmm.
Base condition. If we have root is null, then we have to return it because we don't have anything to do with it.
True.
As we have seen earlier, we won't require that in the this condition.
Mm-hmm.
Mm, yeah, root can be null, so we will be returning nothing, empty list. Yeah, in observation I have written here. And if we have only one, so we'll return that one. But since we can have at any particular node, let's say we are at one, let's say at any arbitrary node x. So first we'll have to travel to its left child and then to the right child. No, sorry. First we have to travel to the left side, then print the node which is the parent of the left and right child, then go to the right child. So
Perfect.
for instance, here in this test case, first let's say we are at one. So instead of printing one, since it is an in order traversal, not a pre-order, so first we'll have to go to the left side. So the left child has two. Now we are at two. Now we will have to check again its left child, which is null. So we aren't printing anything. So we are returning an empty array to this root, which is two. Now we will print two. Then it will travel to two's right child, which is again null. So in the end, at two, we will get an array consisting of only one element, which will be two. Now since it is recursion, we'll again go back to one.
Mm-hmm.
Now one's left child is already discovered, which is two, and our current list is already having two. Now we are at one, and now we will have to put this one or the node's value where we are right now in the list, and then travel to its right child, and then continue doing the same approach again and again. So base condition is done, and recursive condition will be first. I'm writing an algorithm, not exact code, so I'll be using English words here.
Yeah.
Travel to left, or let's say discover left child. Then after, okay, I'll write it here. Discover left child, then put current node's value inside list or the array called ARR, and then recursive spelling, yeah, and then
Sorry,
okay,
that was
so
my bad.
yeah, no issues, no issues. Inside array, and then discover right child. Okay, so since we are now coming to the time complexity and space complexity, since we are using recursion, so we get an idea of the space complexity, which will be linear.
Mm-hmm.
I'll write it here. space complexity, C denotes space complexity. It will be linear since we are having an auxiliary stack space because of recursion calls, and at most we can have n elements in that stack space because we are traveling every node at least once.
Yeah.
And then we are, since we travel, let's say we are at 2, and since we come back to 2, so the nodes below 2 are already visited, so they will be removed from the stack. So at most we can have n elements
Mm-hmm.
if it is a skew tree.
Mm-hmm.
Okay, now coming to the time complexity part, since I mentioned we are visiting all the nodes at least once and only once, because let's say at 2 I have discovered the left child, and then I come back to 2, and then I discover the right child. So we are traveling a node, we are exploring a node at least once and only once, at
Mm-hmm.
most once I can say, at least and at most once. So time complexity will be linear again.
Okay.
Now coming to the recursive, I'll code it out. Let's say I write recursive function's name to be recur,
Yeah.
and then, or let's say, what was the question? In order. I'll write in order, traver, in order traversal. Then this will receive a root. Now since we require an array, so since we don't know the number, I'll be using a vector for now. And are the nodes values integer or long? Okay, integer. Okay, sure. So I'll be using answer as the answer to have the answer of the nodes.
Perfect.
And okay, so the first condition is if root is null. Okay, so here I want to mention we can write null or we can also write null ptr. So I'll be using null only.
Mm.
It looks shorter. So return nothing. Now we will have to discover the left part. So in recursive solution, I will call I will call the left child, which will be roots left, and then I will write answer, passing on the array or the vector. Now we have already visited or already discovered the left part of the current node. Now we'll have to put the values inside this list. So answer dot pushback roots is it data or val. Now we have put the now second condition or the second stage is done inside putting the value inside array. Now we'll have to discover the right child in order traversal. Now we'll visit the right side, and here in the solve function I will write a vector which will be named as answer.
Yeah.
I will call in order traversal on the root and pass on the answer, and then I will return the answer. Okay, so this takes O of n times space, and space complexity will be O of n. Shall I give you a dry run of this code
Sure.
on a test case?
Sure. Yeah.
Because yeah, because I think all the edge cases are already done.
Mm-hmm.
So I'll go on with a random test case. Let's say I'm given a tree. I'll draw it here.
It's fine.
Okay,
You can
so
use the same sample that you have done. You can take that as a
okay,
dry case for this, and then that would be good enough.
okay. So I'll do a dry run on these three test cases.
Yeah.
So first one is let's say I'm giving root as null. So here root is null. As soon as I pass in the in-order traversal, it goes in the one second. Yeah, it goes in the in-order traversal function, and as soon as it finds the root is null, it will directly return it without putting any value inside the answer vector.
Mm-hmm.
So I'm passing by reference here. Uh, this is very important. If we don't, it will again and again copy. So it might give a TLE if the test cases are large enough, and so root is null, so it will directly return. So the answer is returned here, so it won't have any values inside because this part is not getting executed in the recursive function. And now for let's say, okay, let's skip the second one. Start with the this test case because this is basically the extension of this test case.
Yeah.
So let's say I pass the root which is one. So currently right now I am at one, and if root is null, since root is not null, first it will call the recursion again on the left child. So left child is roots left, which is 2. So I'm passing the 2. Okay, so this function passes 2. So now what happens? Again, this function is called, and since root is not null, the current root is not null, which is 2. So it goes like this. I'll write it here. First we were at 1. Go left. Then I am visiting 2. Now again go left using this because this is coming first. This is coming first in the recursion call.
Mm-hmm.
So we'll go left, and then after going left again, since we see 2's left is a null pointer, so this case is encountered. As soon as this case is encountered, the function is returned. So from here, this function is done. So this will return the array which is currently empty to 2. Now we are at 2, and this call is done. This current call. Now, now second line is answer dot pushback roots value. So now we will put this 2 inside our array or the vector. So we are putting this 2. So the list will be modified like this. First we'll get 2, and now since we haven't discovered the right side, second step is done. Then third step is we will go to the right side, which is empty. So again same story. So it won't put anything. Again it will get returned from here. Now press now control goes to 1. Now we will discover. Now before discovering, since this is pushing back the value of 1, now our answer will have 2 1, and then we will visit the right side. Now since right side has 3, again it will visit its right side because it is not null. 3 is not null based
Mm-hmm.
on this condition. So now when we visit 3, its left and right both are null, so nothing will be put inside the array or the vector. Now the control will go back to uh, now the control will go back to 3. Now since we have left as null for 3, we will put 3 and then go to the third's right side. Sorry, I in the previous sentence I misspoke about the left and visiting left and right together. We are visiting left and then we are putting the value of the current node, then we are visiting right.
Yeah.
So we were at 3, we will visit left, we find nothing, nothing is put inside the array or the vector. Now we come back to 3, we will put 3 and then go and discover 3 is right. So our final uh, control will go back to 1 and our recursion call will be over.
Got it.
So in the end, we will get 2 and 3.
Okay. Yeah. This one makes sense. Viewers, even the people who are watching it after the live video, please feel free to contribute your best solutions to the repository. You'll be able to find that in the link of the description. This was perfect, Tushar. I think we can move on to the next question, and yeah, we'll see in that.
Sure.